Thank you. My name is JJ. I'm the chief scientist and co-founder of 2Pi, which is a startup spun off my lab at MIT, focusing on innovative optics solutions. So today, we all live in an information era, and nowadays, more and more information are now being delivered and processed in the form of light. As a result, the optical systems are also getting larger in size and more complex. This has become a showstopper for many applications. So now, if you look closely into an optical system, you find that they really have not changed that much over the past few decades. On one hand, you have glass lenses that deliver high performance, but they have to be fabricated using grinding and polishing that is costly and not scalable. On the other hand, you have polymer lenses or plastic lenses that can be manufactured at extremely low cost using molding, but they suffer from concerns in terms of performance and reliability. When it comes to packaging assembly, you also have to put together one of these lenses one by one, piece by piece, with careful alignment in between them. And as a result, this leads to traditional optical modules that are complex, large in size, and also costly. So we at 2Pi Optics have developed this Matter Plus optics technology to address this challenge. So the main idea here is that we want to leverage mature semiconductor technology that has been developed in the IC industry to transform optics. More specifically, unlike traditional optics, where you are using curved surfaces to bend propagation of light, we actually fabricate these tiny little structures, or optical antennas, on a wafer, and they are designed so that they can precisely control light propagation direction to impart different optical functions. When it comes to packaging and assembly, we can then actually stack and bond multiple of these wafers together, each of them containing an array of these flat optics components with lithographic precision. In the end, we then dice them, each wafer, into hundreds or thousands of packaged miniaturized optical modules. So the end product are these optical modules that has a form factor of a small chip that deliver high performance superior compared to glass lenses, and also low cost and scalable manufacturing similar to that of plastic optics. So now just show you a couple of examples where our technology has already been applied. One example here is a driver monitoring systems, or DMS. So DMS are basically small cameras on passenger vehicles. They essentially alarm the drivers when they're getting distracted in driving. So traditional DMS requires a stack of glass and polymer lenses. They're complicated to assemble. In our case, we can replace all of them with one single piece of our Matter Plus optics. And this gives rise to superior thermal and mechanical robustness, which is critical to meet the stringent demands of automotive regulations. At the same time, we can also provide higher resolution, which is important to improve the detection accuracy and lower the false alarm rate. So through a collaboration with our foundry partner, we have already realized mass production of this type of optics, and they have been delivered to leading Tier 1 and Tier 2 suppliers in the automotive industry, and we have received excellent feedback from our customers. The second example where our technology has made an impact is in augmented reality and virtual reality systems. In state-of-the-art AR/VR modules, you typically have anywhere from 15 to 20 individual optical sensors to perform functions such as gesture recognition, eye tracking, hand tracking, and so on. And as a result, the size and weight of the sensors adds up quickly. In our case, we can deliver sensors that are far more compact, lightweight, and that can also be seamlessly integrated with AR/VR modules. We can offer higher resolution and also a large field of view comparable to that of human peripheral vision, and this is crucial in delivering an immersive user experience. So this performances has already been tested and validated by key OEM vendors across the world, and we are now transitioning into mass production of this product. So in summary, we believe that we have developed this kind of platform technology that can empower many applications across different sectors, from consumer electronics to automotive and robotic sensing, to medical imaging and beyond. So we definitely welcome collaboration opportunities and partnership with you. So if you're interested, please do stop by our booth, and I would love to chat. Thank you.
Thank you so much, JJ.